Hello everyone. Continuing with the concept of energy, today we will discuss the concept that potential energy is path independent. In your NCERT textbook, you have an illustration to show that this potential energy is path independent. So, we know that what is potential energy? Potential energy is equal to M into G into H. So children, what do you mean by the concept potential energy is path independent? That means potential energy depends upon the initial and the final point. It is independent of the path followed. So, we'll take the example where a body of mass m is taken to a height h. So, as you have already studied, what is the potential energy of that body? That potential energy will be m into g into h. Suppose the same body is taken to the same height but through a different path. That I will draw for you. Here there is the mass and we are going to take this mass through this step so that it reaches here, so that the vertical height remains h. Let this height be h2, this height be h1. So what is the work done to move the body from A to B? So we can say that WAB is equal to mgh1. And we can mark it as C here and D here. So what is WCD? It will be mgh2. So you will be surprised why I am not taking this BC. Look, we know that the force applied on the body will be like this and the displacement on BC will be like this, so that the angle is 90 degree here. The work done on BC becomes 0. So what is the total work done, children? The total work done in this case become WAB plus WCD. So we know that this WAB is mgh1 plus WCD is mgh2. So that is mg into h1 plus h2. So total W is equal to mg into h1 plus h2. So W total is equal to mgh. Look, even though we have taken this body through this path, the final work done or the potential energy stored in this body will be mgh only. That is equal to the potential energy, right? And in the previous case where it was directly taken, that also is mgh. This is what is meant by potential energy is path independent. Next, what we are going to study is the energy conservation principle. Energy conservation principle states that energy can neither be created nor be destroyed. It can only be transformed from one form of energy to another. Now let us discuss some of the applications in our daily life where there is energy conservation principle. So let us discuss the example of an electric fan. In that, what type of energy is converted to another? That is, the electrical energy is converted into mechanical energy inside a fan. We know that in an electric generator, mechanical energy is getting converted into electrical energy. What happens in a battery inverter? First of all, the electrical energy is getting stored in the chemicals of the battery. And when the battery is working, what is the energy conversion happening? The chemical energy stored is converted into electrical energy. Let us consider the case of a windmill. What is happening there? The energy of the wind of course the kinetic energy is getting converted into electrical energy. So, in a hydroelectric power project, what is the type of energy conversion happening? The potential energy of the water stored in the dam is converted into kinetic energy of the turbine, which in turn is getting converted into electrical energy in a dynamo or a generator. So, you have to take examples from your outside to show this energy conversion. Another thing that we are going to discuss is about the nuclear power plants. What happens in a nuclear power plant? The nuclear energy or the heat energy produced by nuclear reaction is used to convert water to steam, which can again turn the turbine. There are a lot of examples in our daily life where we can see step-by-step energy conversion. So sometimes you feel that whatever energy is there, it is not 100% converted into work or another form of energy. Why? It may be due to certain dissipation in the form of light, sound, etc. Thank you.